The year was 2010. The world still believed that cyberspace and physical destruction lived in separate universes. Computer viruses were for stealing credit cards and embarrassing emails. Physical sabotage required bombs and bullets. That belief died in a uranium enrichment facility buried deep beneath the Iranian desert. What happened there would rewrite the rules of warfare itself. This is the story of Stuxnet, the weapon that taught the world that code could kill. The target was Iran's crown jewel, the Natanz nuclear facility. Buried underground, protected by concrete and steel, it housed thousands of uranium enrichment centrifuges spinning at supersonic speeds. Each centrifuge was a marvel of precision engineering. Aluminum tubes rotating at 63,000 RPM, separating uranium isotopes atom by atom. One wobble, one miscalculation, and millions of dollars of equipment would tear itself apart. The facility was air-gapped, no internet connection, no external networks. The Iranian engineers thought they had built the perfect fortress. Industrial control systems managed every aspect of the operation. Siemens programmable logic controllers, or PLCs, monitoring pressure, temperature, and rotation speed. These systems weren't designed with cybersecurity in mind. They were built for reliability, not resistance, and that would be their downfall. The attack began not with sophisticated network penetration, but with something far more mundane: USB drives. Someone, we still don't know who, carried infected thumb drives into the facility. Maybe it was an asset. Maybe it was an unwitting engineer who picked up a dropped drive in the parking lot. The weapon was patient. It could wait. When that USB drive was plugged into a Windows machine inside Natanz, Stuxnet came alive. This wasn't your garden variety malware. This was a precision instrument crafted with the resources of nation states. It carried 4 zero-day exploits, previously unknown vulnerabilities that could penetrate any Windows system. 4 0 days. Most cyber criminals would kill for one. This weapon had 4 plus stolen digital certificates to make it look legitimate to security software. Stuxnet spread through the facility's network like smoke through ventilation shafts, but it wasn't interested in stealing data or causing random chaos. It had one target: Siemens Step 7 software that programmed the PLCs controlling the centrifuges. The malware was hunting for a very specific configuration: frequency converter drives made by Vacon and Ferraro Paya that controlled exactly 984 centrifuges. The precision was surgical. This weapon knew exactly what it was looking for. Once Stuxnet found its target, it began its real work. It installed a rootkit on the Siemens PLCs and started recording normal operations for weeks, learning the rhythm, understanding the baseline. Then it began to lie. When operators checked their monitoring systems, everything looked normal. The displays showed steady pressure readings, consistent rotation speeds, all systems green. But that was just the mask Stuxnet wore while it quietly murdered the machinery. The weapon attacked in 2 phases. First, it would spin the centrifuges up beyond their design limits, then slam them back down to crawling speeds over and over. The delicate aluminum rotors spinning faster than jet engines. They began to wobble and tear themselves apart. And the second phase was even more elegant. Stuxnet would interfere with the pressure systems, creating resonance frequencies that would cause the centrifuges to vibrate themselves to death. All while the control room displays showed everything was perfectly normal. The damage was devastating but invisible. Iran lost nearly 1,000 uranium enrichment centrifuges, roughly 20% of their entire program. But the Iranian engineers couldn't figure out why their equipment kept failing. They replaced parts. They brought in new technicians. They suspected sabotage but couldn't prove it. The weapon was so sophisticated that it took months before anyone realized they were under cyber attack. The discovery came by accident. Stuxnet had a flaw. It was too aggressive in spreading beyond its intended target. The malware escaped Natanz and began infecting computers around the world. A security researcher in Belarus found it on a client's machine and started reverse engineering the code. What they found changed everything. This wasn't just malware. This was a weapon of war. The political earthquake was immediate. For the first time in history, a cyber attack had caused physical destruction on a massive scale. Iran's nuclear program was set back by years, but the bigger shock was the precedent. If the United States and Israel, for this was clearly a joint operation, though neither country officially admitted it, could destroy critical infrastructure with code, then so could China, Russia, North Korea, or any nation with sufficient resources and motivation. The technical sophistication was breathtaking. Stuxnet used more zero-day exploits than most cybercriminal organizations see in a decade. It demonstrated intimate knowledge of industrial control systems that should have been secret. The attack required months or years of intelligence gathering, reverse engineering, and testing. This was cyber warfare with the resources of a military operation behind it. The lessons from Stuxnet still echo through cybersecurity today. Air-gapped networks aren't safe. If humans can access them, malware can find a way in. Industrial control systems designed decades ago with no thought of cybersecurity are fundamentally vulnerable. The convergence of IT and operational technology creates attack surfaces that most organizations don't even know they have. More importantly, Stuxnet opened Pandora's box. Nation states learned that cyber weapons could achieve strategic objectives without risking soldiers or triggering conventional retaliation. The threshold for cyber war became lower and the potential for escalation became higher. We've seen the consequences in attacks on Ukraine's power grid, the shutdown of Colonial Pipeline, and countless other incidents where code jumped from computer screens into the physical world. Every CISO today lives in the shadow of Natanz. The question isn't whether critical infrastructure can be attacked through cyberspace. Stuxnet proved it can. The question is how to defend against adversaries with the patience to develop 40 days and the intelligence apparatus to map your most sensitive systems. In the end, Stuxnet accomplished its mission. It set back Iran's nuclear program and demonstrated American cyber capabilities to the world. But it also taught every adversary that the United States had crossed the Rubicon into cyber warfare. The weapon that was supposed to prevent one conflict may have made future conflicts inevitable. The rain keeps falling on the city of secrets, and somewhere in the darkness, new weapons being forged from ones and zeros. And the age of cyber warfare didn't begin with Stuxnet, but it sure as hell announced its arrival. Some doors once opened can never be closed again. That's the case file on Stuxnet. File it under lessons learned the hard way. This is Jack Cipher signing off. Stay vigilant out there. In cyberspace, the next war might already be loading.